Now let's take a look at dividing complex numbers. So I've got the Z1 and Z2, and I just want to look at how do we go about dividing complex numbers. Now, my focus is going to be how we can convert these to trig form and divide complex numbers that are in trig form. But first, I want to go back and just review what we've learned before, probably in a past course, about dividing complex numbers. What it involves is multiplying by the conjugate of the bottom. So we've got 4 square roots of 3 plus 4i on the bottom. So I'll just multiply the top and the bottom by its conjugate. Just replace this plus with a minus. I do that to the top and the bottom. And the bottom, remember, when we multiply a plus b times a minus b, we just get a squared minus b squared. And that's exactly what we've done on the bottom. So a shortcut to this bottom, multiplying it out, would just be to realize that we take the first number squared minus the second squared. And if you look up at the top, we just multiply this out, the way we always do, distributing through 1 times 4 square roots of 3, 1 times negative 4i, and so forth. And we multiply this out. Now, one of the things you notice is we've got this I squared, which that's going to be negative 1, which is just going to change this whole term here to positive 4 square roots of 3. Okay, now, also, notice I've got 12i here. That comes from right here where I have 4 times square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is 3. So this is 3 times 4, which is 12. And now this is what I have. Now I combine 4 square roots of 3 with 4 square roots of 3 and get 8 square roots of 3. I have 12i minus 4i, get 8i, and then 48 and 16 is 64. So there's what I have so far. Now I can divide out the 8, right? So I've got an 8 here and an 8 here. I just divide both of those and I get an 8 on the bottom and no 8 up top. And then if I want to put it in a more traditional form as the real part plus the imaginary part I could write it this way. So here's our complex number that we get from dividing z1 by z2. This is the result of our division. Now what I want to do is convert that to trig form. So I need the modulus. I get the modulus this way. Just the way we always get the modulus. There we go. And we find that to be 1/4. Then before I can write the complex number in trig form, I need the angle. I need theta. So I got theta equals arctan of the imaginary part over the real part. And that just turns out to be 30 degrees. So here's what we have. Z1 divided by Z2 is 1/4 cosine 30 degrees plus I sine 30 degrees. So what I've done is I've just divided without even worrying about trig form, and then at the end I converted it to trig form. Now the reason I did that is because now I want to convert it to trig form first and see how we would divide with it in trig form. So I go through here and I convert these, and I get the modulus, I get the angle, which I'm calling that angle alpha, and I find alpha to be 60 degrees. So here is my complex number for Z1. I do the same thing for Z2. I get the modulus, I get the angle beta, and there's Z2. Now, what I'm trying to do, I want to derive a formula. So we're not going to have to do this every time. What I'm about to do, I'm doing it the long way, so you don't have to. So here we go. I'm going to divide Z1 by Z2, and that's what it looks like right here. Not this part over here, but this part right here. Z1 over Z2. And what this is me multiplying by the conjugate. See? So I'm just multiplying by the conjugate of the bottom over here. But Z1 divided by Z2, that's this part right here that I'm circling. Okay, then I multiply by the conjugate. Let's see what this turns out to be. Well, the bottom is just going to be cosine squared 30 degrees minus I squared sine 30 squared 30 degrees, okay? Because it's still the first term squared minus the second term squared. Now up top, we do all this multiplying out, you know, just like I did before. Cosine 60 times cosine 30. There it is. Cosine 60 times negative I sine 30. There it is. Okay, so I went through there and multiplied all this out, and if you want to, you know, you can study that, pause the video and look that over and see where I get everything. But one of the things we want to take note of is that there is two distinct parts to this. There's the real part here and here. Now you might say, well, that's not a real part, it's got an I. Well, it's I squared, right? And that's going to be negative 1 when I replace, when I replace I squared with negative 1, this whole thing is going to be a positive sine 30 sine 60. But right, so here's a real part, and here's a real part, and here's an imaginary part, here's an imaginary part. So what I'm going to do is group everything group the real parts together and group the imaginary parts together. So here's a real part, which is sine 30 sine 60, and this is plus now. A negative I squared is a plus 1. So I put this over here. There it is. See? There it is. I put it right there. There. See? Now, so I've got the real parts together. Now I took the imaginary parts. Here's an I and here's an I, and I put those together. So I put this part, because it's positive, I put it first. See? There it is. Put it first. And then I took the negative part and put it here, and I factored out the I, because I had an I here and an I here. So I factored out the I. Now, you might wonder, well, what happened to the denominator? Well, the denominator is cosine squared 30 plus sine squared 30. See? Because this I squared, negative I squared, is just going to be a 1. So what I did was I replaced the I squared with negative 1, and what I had was cosine squared 30 degrees plus sine squared 30 degrees, and that's just equal to 1. So that whole thing went away. Now what we have is our result. Z1 divided by Z2 is this. Now you might wonder, okay, how did we get here? Well, take note. Cosine 30, cosine 60 plus sine 30, sine 60. That is the formula for a difference of angles for cosine. That's a formula from the identities part of trig. It's a difference of angles formula for cosine. That's that right there. So I immediately just replace that with this. And likewise, you'll notice that this is the difference of angles formula for sine. So I immediately went down and replaced this long mess here with this nice part here. So you see what we have now. We have 1/4 cosine 30 degrees, this is 30 degrees, plus I sine 30 degrees. And that's exactly what we got when we did the division and then convert it to trig form. So that worked out nicely, and this is a nice shortcut if you think about it. So let's be general here. We've got a complex number Z1. We've got another complex number Z2, which I put them in trig form. What I'm saying is, if you have complex numbers in trig form and you want to divide Z1 by Z2, you divide the modulus, the two moduli. I guess it's moduli. I get mixed up. Okay, we divide these things. And then we say cosine the difference of the angles, alpha minus beta plus I sine alpha minus beta. There it is. That's the formula. That's how we can divide complex numbers.